Good morning, all. Let us start with our next topic in Module 4 Interrupts. As you know, synchronization is achieved by having IO device send a special signal over the bus whenever it is ready for a data transfer operation. That is, the program enters a wait loop in which it repeatedly tests the device status. Right. Actually, IO device sent a special signal whenever it is ready for data transfer. Therefore, IO device can alert the processor when it becomes ready by sending a hardware signal. This particular signal is called an interrupt. Whenever the IO device is ready, it can send an alert to the processor. This particular alert is sending a sending a hardware signal called as an interrupt to the processor. So we know that in the bus we have three lines. One is the address line, the data line, and the third one is the control line. So this one of the bus control line is called as an interrupt request line. This interrupt request line is used for this particular communication, that is this particular signal interrupt. Since the processor is no longer required to check the status of external devices, it can use this waiting period to perform other useful functions. There are many situations where other tasks can be performed while waiting for an IO device to become ready. To allow this, we can arrange the IO devices to alert the processor when it becomes ready, right? So, this interrupt request line is usually dedicated in the bus to send a hardware signal called an interrupt to the processor. Here you can see a figure which shows the transfer of control through the use of interrupts. The routine executed in response to an interrupt request is called an interrupt service routine. You can see here an interrupt service routine. This is the routine which is executed in response to an interrupt request. So here you can see a program and an interrupt service routine. Interrupt service routine is simply a routine which is executed in response to an interrupt. So let us assume an interrupt request arrives during the execution of instruction I. The processor first complete execution of instruction I, then it loads the program counter with the address of the first instruction of the interrupt service routine. After execution of the interrupt service routine, the processor has to be back to instruction I plus 1. You can see in the figure under program 1 the instruction I and I plus 1. Always an interrupt request arrives during execution. Suppose here the interrupt request arrives at the execution of instruction I. Then the processor completes first the execution of instruction I. Then it loads the program counter with the address of the first instruction. After execution of the interrupt service routine, it will be back to the instruction I plus 1. Right. When an interrupt occurs, the current contents of the PC which points to the instruction I plus 1 must be put in temporary storage in a known location. So this is the concept of how we are transferring the control through the use of interrupt. Next comes the comparison, or what is the similarity between the interrupt service routine and subroutine. Actually, these two are very similar. You have studied the concept of subroutine in your C classes. Simply, a subroutine performs a function required by the program for which it is called. Whereas, interrupt service routine may not have anything in common with the program being executed at the time the interrupt request is received. The two programs belong to different users. Before starting execution of the interrupt service routine, Any information that may be altered during the execution of that routine must be saved. So, any instruction that may be altered during the execution of that routine must be saved. And this information must be restored before execution of the interrupted program. The task of saving and restoring information also can be done automatically by the processor or by program instructions. This is because the process of saving and restoring registers involve memory transfers that increase the total execution time and hence represent execution overhead. So this will save only the minimum amount of information needed to maintain the integrity of program execution, and also this comes with a new term that is called the interrupt latency. Interrupt latency is simply the delay between the time an interrupt request is received and the start of the execution of the interrupt service routine. So please note, interrupt latency is the delay between the interrupt request is received and the start of the execution of the interrupt service. Next come with enabling and disabling of interrupts. The arrival of an interrupt request from an external device causes the processor to suspend the execution of one program and start the execution of another. Because interrupts can arrive at any time, they may alter the sequence of events by the programmer. So, a fundamental facility is the ability to enable and disable the interrupts whenever it's required. So, here only 2 points are to note. One is interrupts may arrive at any time, and this may alter the sequence of events. So, we need an interrupt enable or disable function whenever it's requests. Next, let us see a specific case of a single interrupt request from one device. When a device activates the interrupt request signal, it keeps the signal activated until it learns that the processor has accepted its request. This means that the interrupt request signal will be active during execution of the interrupt service routine. Also, it is essential that active request signal does not lead to successive interruptions. It leads to the system to enter into an infinite loop from which it cannot recover. For this, there are three major mechanisms to recover from this situation. One is to have the processor hardware ignore the interrupt request line. The second one is to have the processor automatically disable interrupts. And the third one is to add a line called as edge triggered. Let us see each one. The first one, that is ignore the interrupt request line. So the first possibility is to have the processor hardware ignore the interrupt request line until the execution of the first instruction of the interrupt service routine has been completed. Then, by using an interrupt disable instruction as the first instruction in the interrupt service routine, the programmer can ensure no further interruptions will occur until an interrupt enable instruction is executed. The second one is suitable for a simple processor with only one interrupt request line, which is the concept of the processor automatically disable interrupts before starting the execution of the interrupt service routine. And the third one is the processor has a special interrupt request line for which the interrupt handling circuit responds only to the leading edge of the signal. Such a signal or such a line is said to be an edge triggered. So there is no danger of multiple interruptions and no need to explicitly disable interrupt requests from this line. So let us summarize the sequence of events in handling an interrupt request from a single device. You can see here a set of 6 events. It simply shows how we can handle an interrupt request from a single device. The first one is the device raises an interrupt request. As you know, first the device raises or the device will send a signal saying that it's an interrupt. The processor interrupts the program currently being executed. So whatever be the processor doing, that will be interrupted. Then the third step is interrupts are disabled by changing the control bits in the PS. So this PS it's a register. It shows the processor status register. So what here done is interrupts are disabled by changing the control bits. As you know, bit 1 shows it is active and bit 0 shows it is inactive. So similarly in PS means the processor status register. So there are also control bits. So we can change the control bits by showing that to be inactive. Then the fourth step is the device is informed that its request has been recognized. And in response, it deactivates. And the fifth one, action requested is performed by the interrupt service routine. And finally, the interrupts are enabled and execution is resumed. Let us continue the part 2 of interrupts handling multiple devices in the next class. Thank you all.